Hello, my name is Noah Collin. This is my final project. I just want to give an overview of what I did for my project and then I'll explain the code a little bit. I made a hybrid system where it uses ALS matrix factorization, which works well when there's an adequate number of ratings, but falls apart if there's very few ratings for a given movie. So the second system I used is text from the plot to see how text from the plot compares to other things you watched. And I did it with an embedding model, so it uses semantics. And I'm going to show you a little bit about the distinction between a bag of words approach and a semantic approach. And then at the end of it, as a stretch, I had two stretches really, actually. One was not my prompt, and one was the first stretch was I used a Gemma model, in other words, something that can run on my laptop, to look at the plot of the movies that were recommended to you, or that you liked rather, and then look at the plot of the movie that is being recommended to you based on the hybrid system. And don't forget that that hybrid system has ALS, which makes latent factors which can't be known and aren't human intelligible. So it's kind of a post hoc reconstruction of, given that you liked these movies, here's why we think you would like this movie, but just based on text with an LLM. And I did that again with a deliberately small model. And then I had Claude evaluate some of that small model's responses to see how true that is. That was the stretch that I didn't mention in my um, write up. So let me get into it here. This is just saying we're using the 25 million data set, ratings data set. So here's the Spark setup. This is you are pointing your PC or whatever, it could be your cluster, at Spark, the Java library, and then you make a Spark instance. This local means that it's just this PC only, and that asterisk means that you're going to just use all the cores on your PC, but that's where you would change it to be a cluster. Okay, load the data. How sparse? 99% sparse data. Um, most of the ratings are a 4, but you can see there's very few low ratings, and that's going to come up later when we talk about the problem with root mean squared error a little bit, that some of the movies get RSMEs of nonsensical numbers like 5 and 6. I mean, above 5, excuse me, and 6. Okay, again, the key takeaway from just data analysis is 99% sparse data. Okay, here's the train test split. I looked at a baseline alternating least squares with no tuning, and then I did it with a grid search and also with a cross validation to see if that would actually improve anything. And you can see here's the different grid search results and the cross-fold validation. So I have a little uh, data frame. Here's the data frame of what happened. It took on this machine 14 seconds to do the baseline with the default, with just kind of randomly chosen parameters. This means there's only 10 latent models, 10 latent features, excuse me. Yeah. Grid search, which took 3 minutes, and the cross-fold validation took 14 minutes. This actually gained something compared to baseline, but this gained nothing compared to the cross-fold validation, gained nothing extra. So it's worth it to do the grid search. Also, just mentioning that the grid search hit the boundaries of the grid search, so maybe I should have used more values, but I just moved on. Does it actually recommend? Okay, so yes, most movies have very few ratings. Um, let's look at a different plot. So here is something that I found a little surprising with this plot. The orange is the median number of ratings, and with a different floor. So we set a floor that we're going to filter out things that have too few ratings from being recommended. The model stays the same, but we're not going to recommend something with one or two ratings because it's possible its RSME is kind of poisoned, like I mentioned earlier. And uh, you would think that if you're not filtering out anything with the blue one, how many distinct recommendations would there be? If you're not filtering anything, you might expect that to be off the charts. But the counterintuitive finding and interesting finding is that when there's no floor and you can recommend anything, everyone is getting recommended these, you know, very few rated, and just because of the latent factors, extremely high rated movies, and the distinct count for recommendations goes down when there's no floor set because everyone's getting recommended these same incorrectly through linear algebra, through linear regression, um, highly rated movies. So once you actually implement a floor, you see an uptick initially of distinct recommendations, and then it does go down, obviously, as you'd expect with the floor. Okay. Here's what the movie's about. This was, you took the plot from a different data set, and uh, the plot was compared in two different ways. I'm just going to show you here. Here's the TF-IDF means bag of words. I forgot what the acronym stands for right now. Inverse, I'm forgetting. But it's bag of words. And something that's kind of funny here is with most similar to Toy Story, yes, Toy Story 2, but 40-year-old virgin. That's because Andy is the protagonist in Toy Story and in 40-year-old virgin. And here's Andy again in The Hot Blonde Trouble. And Andy Kaufman plays, in other words, Andy was in the plot text of Toy Story, so I'd recommended these silly things. And then, okay, here's the embedding one with the Gemma 3 million embedding parameter. So it uses, semantic context to compare texts. So it recommends Toy Story and Rebel Without a Cause. I don't know what these movies are, if I'm brutally honest, but one of the checks that we did is here's the genre crossover. With the bag of words, only a 50% genre crossover, but with embedding, it's a 64% genre crossover, which means it's recommending things in the same genre, which kind of is a proxy for it's making better recommendations. Uh, okay, let's just okay. This is the hybrid approach where I'm just saying I'm gonna use the two things I mentioned at the same time: the basic ALS matrix factorization and the text thing I just mentioned. So here's the interesting chart. Um, you can see here the green one is the text comparison. I'm probably way over time already, and the blue one is the pure collaborative filtering ALS, and the orange is the hybrid. You can see that when the two things are combined, even though um, collaborative filtering falls apart when there's very few ratings, when you account it with the text, the error gets is considerably better. This is the strength of an ensemble model, that the two things are being weighed. And I skipped over something, but the algorithm that we made, uh, it's a weighted algorithm. It's somewhere in the notebook where it considers the number of ratings it has in weighing how much the text is going to impact the hybrid model and how much the ratings and the ALS are going to impact the hybrid model. But so in other words, the one interesting thing is the hybrid model can also recommend models that have no ratings because it can just go off text, and that's built into the little weighting algorithm. But yeah, you can see that when ALS falls apart because there's too few ratings and the error is very high, even though the text model is not great on its own, when you combine the two, it gets considerably better. And then at some point, ALS just takes over, and you're not really losing anything except a little compute to still work with the hybrid system. And it's impossible to see here, but the hybrid system actually does a smidge better than just baseline ALS. So that's the key takeaway from my whole project. That's most of what the course content really was. So this is the stretch part. So I'm going to fly through this. Let me just say that I couldn't really get Gemma on a loop to run in a Jupyter notebook. So there's a subsequent outside script, and this reads in that script's results. So here's what the data looks like when Gemma evaluates. It's passed in all the plots of the movies as text. Again, it can't see the latent features. That's definitionally impossible. So there's a reconstruction. So it's gonna see. Um, I saw that sometimes this was a bit iterative. Sometimes if the depending on how I worded the prompt, I would get slightly different results. So I made a vivid one, terse, tropes, so that was kind of genres and critics. And then I had it synthesize itself and also judge itself as to which was better. And in other words, this synthesized one is going to be what they're actually shown. But it gets the plots of the movies that you actually like and the recommended title. It gets the plot and it says, given that the user liked these and this is the plot of this one, why do you think they would like it? In other words, it's already being served things that are from the hybrid system, the ALS mostly, being told the user does like this. Why does the user like this? We're having the LLM write that up. And so here's what the user would actually see. You like, Schindler's List and The Godfather, just as these films explore the individuals navigating the pressures of a large-scale conflict and social upheaval. And again, who knows, that's kind of small model gibberish. So I evaluated it with Claude. Okay, so let's see. Here's kind of Claude's evaluation of how it was a Gemma 26 billion, Gemma 4, 26 billion model. It's kind of like a smaller performant model. What is Claude? I told Claude to go do internet research, think about the recommendations. And so basically, it said overall they're pretty accurate. Sometimes it's thin but honest. Okay, so let's look at an example. Um, the dawns here are quiet. I've never heard of that, but it likes these things. The plot we gave it. Here's what Gemma made with the different prompts. Um, Here's the synthetic prompt that eventually the user would see. What does Claude think about it? It's faithful, uses its own words. There's a source error. I had it look for that because the overview calls it a corporal. He's actually a sergeant major, and that's kind of the mistake that it made. An after World War II small unit drama faithfully argued from the plot. The lone blemish is a rank error. Opus traced online to the plot. I mean, it's just so. This is a little write up of 20 examples of what a big model and an LLM as a judge thinks about a little model. And basically, if you look at this data frame, it's mostly accurate, it's mostly faithful. Here's embellished. I think there was one example where it said that was the one embellished example, right, out of 20. And I actually did 20 rows because when I did the first 10, none of them came up as anything but faithful. So I was wondering, is anything going to be, a stretch? And you can look at this. I did look at a few of the rows. It is pretty interesting. But in other words, this is a way that you could serve like a one sentence explanation of why you're making a recommendation with an LLM So you have the ALS making latent based predictions that are not interpretable, and you don't want to show end users, plots and data. They just want a one sentence of why you might like this. And here's a, look at how well a small offline cheap model could do it. So you don't have to, spend Claude money to make sensible explanations to end users. That's my project. Thank you very much.